Hello students, this lecture is about the different types of HVDC link. So there are three types of HVDC link. Number one, monopolar link. Number two, bipolar link. And number three, homopolar link. So one by one, we will see and discuss all these three types of HVDC links. So first of all, monopolar link. As the name suggested, mono, here in this HVDC link, there is only one conductor to transmit the power. Here you can see the AC power is fed into the system, and this AC voltage may be at the generating stations, and this generating voltage is stepped up with the help of step up transformer. Then this AC voltage is fed into the rectifier, that is converter stations at the HVDC substations. This AC is converted into DC with the help of these rectifiers. Then this power is transmitted preferably to negative current terminals. At the receiving end, there are inverter stations. These inverters convert DC into AC. This AC power is again stepped down according to the need of the load. So this is the basic structure of HVDC monopolar link. Here single conductor is used to transmit the power, and for the return path we use the earth or sea for completing the circuit. This earthing of pole is done preferably about 15 to 55 kilometer away from the terminal stations. Also, we prefer to provide the negative current conductors, because the in the negative current conductor corona losses are minimum. So this is all about the monopolar link. Now we will see the bipolar link. Bipolar link, as the name suggested, there are two conductors to transfer the power. The main advantage of monopolar link was that it contains only one conductor to transfer the power, so its initial cost is very less. But drawback of monopolar link was that if any fault occurs in the transmission line, then uh, the whole system will collapse. But here there are two conductors, so if anyone uh, stops to work due to the fault in the line, then other conductor will transfer the power, and uh, return path will be the ground as it was in the monopolar link. So this is the main advantage of bipolar link, that its reliability is high. One more thing is that the power transfer capability of monopolar link was very less, because there was only one conductor to transfer the power. But here in bipolar link, its power transfer capability is just double. The structure of bipolar link, we can see that here is AC generator. This AC generator is feeding the power into the system. With the help of transformer, the voltage level is stepped up. This stepped up power is fed into the rectifier circuit. This is the positive polarity conductor. Power is transferred to the inverter and taken out. This output power is again fed to the transformer. Transformer step down the voltage and again fed into the AC system according to the need of the system. Here you can see for the return path, there is negative polarity conductor, converter to here inverter, and rectifiers are same as it was in the positive polarity. So here the power transfer capability is just doubled, and the power is transferred in this closed loop. In case any fault occurs, then the path will be conductor, and so in this way power flows. It is the most commonly used system because it has high power transfer capability and its reliability is high. Only drawback is that it requires the two converters at the sending end and two converters at the receiving end. So its initial cost is high. So it is all about the bipolar link. The third type of HVDC link is homopolar HVDC link. The drawback of bipolar link was that there were two conductors of opposite polarity in that system. So there was requirement of high insulation cost. So to reduce the insulation cost, this homopolar link is the solution. In the homopolar link, there are two conductors which transfers the DC power, but they are of same polarity. Like here in this diagram, you can see that there is negative polarity conductors. Both are negative polarity conductors which are transferring the power in the system. The diagram is same here. AC system is there which is feeding the power, and this AC voltage is stepped up with the help of transformer, and this power is fed into the rectifiers. Rectifier is converting AC into DC. This DC power is transferring with the help of the long negative polarity conductor. After transferring the power at long distance, at the receiving end, inverters again converting this DC into AC. This AC power is stepped down or stepped up according to the need of the another AC system. So it is all about the different types of HVDC link. Thank you very much.